Another example of greedy algorithm is job sequencing with deadlines algorithm. So this is used to determine the sequence or the order of the job which is completed within their deadline and give maximum profit. So we have different steps in doing this algorithm. So first, sort the job in decreasing order of their profit. Okay. So we want to determine which is the highest and which is the smallest. So we want to organize it first. And then second, find the highest deadline among all the deadlines and draw a Gantt chart up to that deadline. So highest deadline means that's the end of our Gantt chart. And third step, assign time slot to individual job IDs. So start with the highest profit, put it in a Gantt chart, then go proceed, then next to the next job, put it in the Gantt chart, etc., etc. But there are rules when we put it in a Gantt chart. Okay, so again, pick the maximum possible time slot for the job based on the maximum profit going to the minimum profit. Okay, aside, then choose another job. So in case if the slot on that deadline is already been filled up by other job, put it in a um earlier, earlier deadline. Okay, and in case if it is impossible to process it, so it means it will not be processed, the job will not be processed, so it will not be allocated. Okay, and then continue this cycle until you get the last, or you analyze the last job. So at the end of the analysis, we could calculate the maximum profit and determine the feasible job and the sequence of the job. So let's have an example. So we have 6 jobs, we have deadlines, and we have profits. Okay, so job 1, 5, 200, job 2, 3, 180, job 3, 3, 190, job 4, 2, 300, job 5, 4, 120, job 6, 2, 100. So first step, organize our job based on the profit, which is higher. So in this example, it's job 4, followed by job 1, followed by job 3, then job 2, then job 5, and list is job 6. So this will be the new order. So this is the one that we're going to use in our sequencing. Okay. So after organizing our jobs based on the profit, now we're going to determine the Gantt chart. So the Gantt chart is based on the highest deadline. So based on this, the highest deadline is 5. So it means we have 5 slots. So 5 jobs need to be accomplished based on this given problem. Okay. So from there, after determining the size of the Gantt chart, now we're going to allocate first the highest profit, which is job 4. So the deadline is 2, so therefore we put it in the second slot. And then job 1, deadline is 5, so put it in 5th slot. Then job 3, deadline is 3, so 3 is empty, so put job 3 on it. While in job 2, the deadline is 3, but unfortunately, third slot is already been filled up by job 3, so look for an empty slot, earlier empty slot. Okay, so in this example, the early empty slot is the first slot. So we put job 2 here. So it means job 2 will be processed first before job 3, job 4, and job 3. Now, going back to this table, job 5, deadline 4. Fourth slot is empty, so therefore job 5 could be allocated, it could be processed. While job 6 is deadline is 2, unfortunately, second slot is already been filled up by job 4, and there's no empty slot before the second slot. So therefore, job 6 is not allocated and it will not be processed. Only job 1 to job 5 will be processed based on this problem, based on the deadline. Okay? So again, job 6 is not allocated, therefore it cannot be processed. So what is the optimized sequence based on our analysis? So it will be job 2, followed by job 4, job 3, job 5, and last job 1. And the maximum profit is 990. Okay? So that's how we implement this algorithm. Another example. Now, let's have 9 jobs. So the profit is from 15 to 85. So let's organize this based on the profit. So the highest profit is 92, followed by 85, then 80, 55, 40, 25, 19, 16, 15, and the deadlines. Step 2, determine the Gantt chart. So how many slots based on the deadline? So look for the highest value in the deadline. So we have 7. So it means we have 7 slots in our Gantt chart. Okay, 7 slots in our Gantt chart. So let allocate 7 job 7 first. So deadline 2. So therefore we're going to fill up the second slot for job 7. Job 1, deadline 5. So fifth slot for job 1. Job 8 or J8, deadline is 3. So third slot in our Gantt chart. Then job 5, deadline is 4. So fourth slot. How about J4? Deadline is 3. Unfortunately, third slot is already been filled up by job 8. So therefore, look for an empty slot earlier than the third slot. So which is the first slot. So put J4 in the first slot. Then J2, deadline is 4. But unfortunately, it's already filled up and as well as first to third slot. So therefore, J4 will not be, J2 will not be allocated. How about J6? Deadline is is 5. Unfortunately, the fifth slot is already been filled up by J1 and also first slot to fourth slot is already filled up. So there's no empty space before deadline 5. So therefore, J6 will not be allocated. How about J3? Deadline is 3. And same as with J2 and J6, 3, 2, 1 slot is already been filled up. So therefore, there's no chance to allocate any allocation for J3. How about J9? So deadline is 7. So we put it on the 7th slot. So what will happen again to J2, J6, J3? Not allocated, therefore, it will not be processed. Okay? So what will be the optimized sequence? So it is J4, J7, J8, J5, J1, and J9. And the maximum profit would be adding all the profit from these jobs. So the result is 367. Okay, so that's how we implement this sequence algorithm. So thank you for listening. See you on the next video lecture.